here's where I left last time. Here's where I left it last time. So basically, I opened up one of the Oracle boxes. So it's kind of visible what it's doing, right? Which is flagging that. And then I was kind of going through Craig's blog post about this concept here, the sort of, because this is not a traditional control node, but it's a control node on an on minus off qubit state. But the way that Craig puts it in the blog post is like you have to understand these being a negation of the entire x-axis of your system, which is kind of, this is a bit what's giving me trouble, because you think about block sphere and that's kind of one qubit, but it's not so straightforward to think about the system, because then it's not anymore the block sphere. It's kind of, it's the space. I don't know. It's the Hilbert space. And it's kind of, but one of the things that I kind of realized is that at the end of the day, what this does is, which is actually what he means, is it negates the, so you've got to imagine it negates the, it basically negates the x-axis if the kind of control, I'm lacking the words for that, because the Z basically what it does is, right, let me just open another quirk, clean one, so I'll show you what I mean. So what the Z does, right, what a control Z does is here nothing, right, because it's 0 0, but it, and if it's like that, it also does nothing, and if we bring that back to 0, and that it also does nothing. To what I mean is, to the phase, right? Obviously, because I just put a 1 here, now the state changed to 1 0, but only in this case the phase is flipped, right, to like 180 degrees. Yeah, but that doesn't. Because if you think in terms of the z-axis of the block sphere, right, pay attention that both cases we've got pointing down. So this is this is the condition the control z needs, right? Whereas if I now want to do the controlled x, but like it's the control x cx c sub xx, so it's like it's not the control is on the x-axis, right? So and we could just go back to 0. So first things first, the interesting part is that it seems to create an entanglement. Well, yeah, of course, because that basically unfolds into a Hadamard. So yeah. But if we let me put block spheres in here. So in this case, you've got a phase of 0 0 and a phase of 0 and of 180 degrees. That's interesting. Well, yeah, because it's 1 1. So for the state in which the thing is, I understand that makes the notation more complex, but I like to know that there are Hadamards inside, because that is what helps me intuitively understand Grover's algorithm, in terms of we are creating a superposition, then we are flipping some of the phases so that when we apply Hadamards again to kind of create interference, then the state that we're flipping is the one that kind of sucks up those amplitudes, and this is the one that you kind of, by iterating over that, and get this the increment and the amplitude. And so the way that I see this is, if we put them all in the minus state, and the minus state. Then you get you see, but that tool is awesome because it allows me to really kind of take a look at a lot of the details without having to change the circuit, because now I can do this. And if you see that before this is applied, basically what has happened after I applied that with that setup is that it literally negated all the phases. You see, it actually and that's what kind of Craig means, I think. And I think there's an equivalent to that if I sorry, I hope it was not too loud. And then there is an equivalent with the with the poly, the Y gate. Because if I let me open another work, I'll just copy paste that. That's awesome, really. This tool is awesome. Yeah, does this work? Yeah, so I'm gonna change this for a Y, and I'm gonna use the Y-axis control, and I'm gonna put it into, I think it should be -I. Yeah. So exactly. So that actually it has the same effect. You see. So exactly. So it basically negates it negates the phase. One of the things that was kind of mind blowing, as I was reading about it, I kind of came back to. It usually happens to me. I keep messing up mentally about what is really how do you really represent the face in a block sphere, because, or is it at all represented? Because, and maybe, and that's what I hate about the block sphere. And it's that if I put that into the minus state, right, and now I apply like an X raising gate. So what this is doing is it's rotating through the X-axis, right? I mean, this is changing the phase. That's what's confusing me, because I always thought the phase is just represented by the Z axis, right? So that's a phase of 180 degrees. But here, nothing is changing in the block sphere. But but I think I know. It's the fact that the relative phase never changes. Correct? Yeah. It's always 180 degrees. That's the point, right? So if instead of that I put an X, like a quarter rotation, right? Yeah, but it's that the relative phase of your whole system is 180, but still you got, because you're in a superposition, you got this has a particular phase of 45 degrees and this is a particular phase of minus 135 degrees, which still this can have an impact, I guess, in your calculations. Yeah, it still confuses me. The block sphere still confuses me when we get into superpositions or multiple qubit systems. That confuses me. Maybe someone can explain me that. But essentially, that's what we're seeing, right? Is that when you have an access controlled operation, what you're doing is you're negating the phase. And so in this case, you've got like this is 0, and here is 180 degrees. This is 90 degrees, and here was minus 90 degrees, and here is minus 90 degrees, and here's 90 degrees, and here is 0, and here's 180 degrees. So that kind of, okay, that's good. So we understand that. Good. Now here, the way this translates, right, is okay, so that would be the same as putting it all of them at one, right? So I could as well just get rid of that. I think exactly, and just do it like that, right? That will work as well. Just so I understand the tool correctly. So then you get into superposition. This is something I still have to figure out. But I guess the reason here is this. What this gate does is, for that state 1101, it flips the face, right? That's what we see here. It flips the face. And now we apply this is where I kind of got stuck, and I'm still a bit stuck. So now the step from here to here, because now what we're doing is we're applying an x-axis control x, which basically means, as we have already now seen for this example, that it flips all the faces. But that again works only when you are in a pure superposition. This means you are like literally in a pure superposition state. So you're like, like you're flat here. Otherwise, that has a different effect. So if you just to show you what I mean. So if you have if instead of a minus state, right, you have something that is a I don't know how can I do that? Can I add I should add a y, I think a y rotation of like a quarter or something. Yeah, exactly. So if you have something like that, and I think I can replace that by this, and that should have the effect that I'm talking about. You see how this is moving, right? So it's kind of doing that circle. So this is not just negating the phase, but it's also changing the amplitudes, which is, I thought that would be the key to explain what's happening here. It's like, but it is not, because here we've got everything. It's everything. 180 degrees, 90 degrees, 180 degrees, 90 degrees is everything flat. I mean, so you basically, but when you do that, right? What are the block spheres looking like here? Does anything change at the qubit level? No, nothing changes at the qubit level. Nevertheless, you've got that phase of that state flipped, right? Nothing else here. And so what happens, because this is this one and this is this one. So here's 0 degrees and here is 180 degrees. That's what the effect of this gate. And now the effect of this gate should be that, but there is indeed a change in here with this qubit. That's the 0, 1. Interesting. And here. And here. Okay. It's flipped them a little bit. So what this is doing is supposed to negate all that. I think the block spheres just confuse me here. I think they're not helpful at all. Because what's happening here is, if you pay attention to every single one of those states, the phase has been negated as expected and as kind of discussed in here, when this is not the case, right? So the phases are being negated, but this one in particular doesn't get negated, stays as it is. The phase doesn't get negated, and the amplitude though increases. The thing is, this amplitude must come from somewhere, right? And as you see, the amplitudes of the other ones the magnitudes are smaller, right? So and this is what I'm trying to figure out how this case works, because intuitively speaking, because the Hadamards are not visible in the picture anymore, and that's causing me a little bit of brain pain right now. Brain pain. Trying to reason out loud. Because maybe I should open Craig's post again. Algassert. Oh, by the way, I should definitely add work in here. and then get a blank circuit. Oh yeah, that's definitely a quick link to have. So thinking of operations of controls, that's the article. Some blah 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 blah. Specific control operation has direct specifications of how to phase Hilbert spaces. This is of course a very useful tool for intuition when thinking about quantum circuits. For example, the controls only approach makes Gross algorithm simpler in two ways. First, it pushes you to think in terms of the overlap between the solution vector and the diffusion vector, which leads to the elegant of what Gross is doing. Second, it makes the circuit a whole model. Yeah. Remember that interpretation. The diffusion vector. Okay, because definitely here, as you can see, it's a bit of a different specific cases. This, what is it really happening here? Come on. So I would say the whole thing gets negated. The phases get negated. The problem is you've done this here, right? So you've introduced this here, and but for some reason this one doesn't get flipped, right? And the only reason that I can think of is that, well, it doesn't get flipped because why? Because we see here the flipping only happens in those cases, right? So what if I have a what if I have one of those being plus? Then nothing flips. Yeah. So they all must have a here nothing's flipped, right? As you can see, nothing. Because all the qubits must be in the minus state. The thing is here, it seems like all the qubits are in the minus state, but that doesn't happen nevertheless for that case, right? And the only way that I could see the amplitude changing is exactly because this is flipped this way. X-axis. How the hell? How is this even an x-axis negation? Like, how is it that this turns that qubit particularly in like upwards and those qubits downwards? Is it because what is an X gate doing? So let me get another quirk, and I want to get an X gate. Can I just like get rid of this one? A block sphere and rotation in the X, and sorry, the block sphere is here. Okay, it goes through, of course, the x-axis like that. Okay, because that's the x that rotates. Yeah. So the amplitudes are changing. No, because I was kind of thinking, for some reason, it seems to be rotating along these. Okay, but let's think about the fact that this is rotating. This is not an x-axis rotation. This is actually it's actually negating. It's actually negating the it's actually negating the x-axis. So it's effectively, so this is effectively a a y rotation. What if I change this for this one? So I'm flying another one. You see, they all go up. Okay, and then that's the one that I'm looking. That's the one that I'm funding now. Yeah. But the that's interesting. The qubits that are being I kind of feel uncomfortable because I feel I'm going up and down different abstraction levels, and that's complicated because this is not like you're not flagging those qubits anyhow. What you're doing, this whole operation, I understand it as the state that fulfills this 11001 basically gets a phase flip, right? Which is 1 1, which is this one, 11001. 11001. An important thing to note is, because sometimes I think that gets me confused, this is the lower level qubit. Okay. So that gets flipped, right? Right. Okay, this ignore here because I should change those boxes to kind of mark the same. So just like I'm just kind of working up until this point. So forget about everything else that's here for the moment. Yeah. So basically, that's what's happening. Interestingly, these two qubits go up, and I mean that definitely reflects that the amplitude here is upper, right? But why is this operation? And at the end of the day, I think what's happening here is that the Hadamards, this has a Hadamard. These things, that's the problem, is that I can't get rid of this. I can't get rid of the Hadamards in my head because that's the exact reason. Because those elements, for this condition to happen, those elements are negated, right? Then the Hadamards act in a different way. So it's like if those, because there's a Hadamard here, and those Hadamards will just put it up. Then there's going to be an X, and then there's another Hadamard. So remember, this is surrounded by Hadamards. But I don't like that. I'm trying to understand that at the level of this operation being applied to the whole system. That's what I don't want to. I want to see if that helps me intuitively. Like not seeing the Hadamards. Like this has for me a clear system effect, which is it flips the face for that particular state. What is this doing? So I'll just maybe have to assume that what this does is because if I didn't apply that, right? If I didn't apply that, no oracle, no nothing, then basically that's literally the same as this one, correct? Looks like. It just flipped, of course. It flips all the phases because that's the expected behavior. But as soon as we add the oracle here, it basically, I gotta get rid of this. It's just distracting me. just distracting me. Yeah, basically that's kind of what's happening. And it's hard. It's just hard intuitively because and maybe I just shouldn't worry about this, but because I had already an intuition about Gross algorithm, but I'm trying to understand because I think that's a useful construct, and I like that it works for for the x-axis, that it works for the y-axis as well, and I think that that's definitely one of those primitives that can be used later on for other cool stuff. It flips the phase 1 1 0 1 1, and the opposite is this one here, so the opposite is 0 0 1 0 0, which usually should be opposite. That's difficult because it seems like you're paying the price of not flipping back the phase for just getting more amplitude. And of course then I understand, right? So then you're doing the same thing, so you're flipping it again, right? And then you apply the same thing, and then the same thing happens, right? So if I put another amplitude display in here, that stays the same phase, everything else has moved, and that just has more amplitude. But I can't get rid of the Hadamarts in my mind, because that's for me what the Hadamarts are doing hiddenly in here. Just that I need to understand. It bothers me. I need to understand what is the system-wide change that is happening, because I understand the system-wide is that it's negating it negates the stuff. It negates the axis. The core point here is that when doing quantum computation, it's intuitively useful to see operations as controls as basically interchangeable. Every operation defines control. There's no inherent reason to stick to the conventions of classical computing. For example, from the view of single qubit operations as controls, it's trivial to define what classical computation is. Classical computation is what you get if you can combine z-axis control with exactly one x-axis control. The x-axis control is the node in the CCC node. Quantum computation is more powerful than classical computation because quantum computation can apply multiple x-axis controls. In fact, that Toffoli plus Hadamard is universal for quantum computation. Proof that support for a 2 must. Okay, here. So what we're doing in the above diagram is describing operations in terms of the eigenvector they affect. Instead of thinking in terms of a specific qubit being turned conditionally, we're thinking in terms of a direction in Hilbert space being negated or phased. We're thinking in terms of the whole system instead of its parts, and that's this I see here. I see that all the stuff gets flipped, but I don't see why. If you mess up with that, so if you're flipping this phase, why that turns into an amplitude change. This is what I kind of don't see. Come on. Because my logic just tells me, yeah, then this would just flip as well. but it's obviously not what's happening. The phase literally means that that has a minus value, right? And because I know that there are Hadamards in here, I know that that's going to create interference. But again, that relies on me knowing that there are Hadamards here. Because then that interference explains this, right? There's a minus in here. And if you're going to apply the you can apply those. Hadamard said Hadamard is an X. Is that correct? Probably. Hadamard Z. Hadamard S. Yeah. Because that's also what's happening here. It's confusing me is the and if I say Hadamard and Hadamard and Hadamard and Hadamard and then control. Where is the yeah, that changes the amplitude, of course, that's why. Yeah. But it's because of that's because of I can't like the Hadamards, because the thing is this would be a Z if we unfold all those Hadamards, right? Which is basically what you've got here. So is what you got here. It just I can't get rid of that. I'm sorry, I can't get rid of that. Maybe I don't know. Maybe I'll come back to this at some point. It's just I can't see this in terms of. I understand that's a more compact notation. That makes sense because I think that that makes sense, but it doesn't help me understand the effect here. The effect here. It doesn't help me to understand the why of the amplitude increase. Whereas if I keep the Hadamards in mind, it definitely helps me understand that from the perspective of, the Hadamards are used to kind of create uncertainty and then destroy uncertainty, so the interference thing. But because we're messing up with a phase in between, then when we are doing the interference, stuff cancels out and stuff adds up. So and that gives you that effect of the amplitude, kind of going there. Going there where we're supposed to go, but this doesn't really help me. So come on, I don't like giving up on this. I really don't like giving up on this. So it's got to do with the fact that also how the amplitudes are, how the phases are here set up, because as soon as you go by to zero, that trick doesn't work anymore here. That trick doesn't work anymore. So that's a specific implementation of Grover's algorithm. The trick doesn't work anymore. Well, it kind of does. It kind of does by having the opposite effect. That's the less probable element. It's interesting. Yeah. Okay, so it kind of does actually. Interesting. But if we put it to 1, then it's the most probable, and that's what you want. Yeah, so that negates all the phases in this case. But because this phase was already negated, amplitude. I'm missing something, I guess. I'm just missing something. Oh my god. That's pretty brain stretching so far. So, again, I understand the effect of this. Correct? The general effect. But of, what does it do if, again, if this were all zeros? If they're all zeros, this actual, that's interesting. There's no effect, right? Because they're all, okay, because there's no negative. There's no negative phase. It's all positive phases. After, like, look, so before the oracle is applied, it's all like that. If I would say that I want to apply this here also, this, just so I get it. So, and now I take a look at the amplitudes here. Nothing's changed. So this doesn't have any effect, right? If they're all 1, then it actually has an effect. If this is 1, 0, right? For those where there is a 0, nothing changes. That's interesting. Okay, nothing changes. Where does it change? No, nothing changes, actually. Absolutely nothing changes. Okay, absolutely nothing changes. Must be everything 1. And it must be all, because if there's no Hadamard, what it's doing is actually creating all those things. It's stealing. It's basically, because the Hadamard's in here, so it's basically taking a little bit of the amplitude and spreading it across all that stuff. Whereas if they're all zeros now, zeros, 0, 0, 0. It's kind of doing the same. Okay, but let's go back to where we were. So we were having Hadamard in here, because that operation works on a superposition the best. So in this case, after that, it flips everything, because they are all in these and these, right? They are opposite. I think I know. Of course, I think I kind of know. So this acts, of course, this what it does is, so what this does is it negates the x-axis, right? it negates the x-axis, because I'm trying to find a definition of that works for all the inputs, and that helps me understand why there isn't a change in amplitude here. Because what this does is it negates the amplitude as long as there's like a negative uncertainty, right? Like the one minus off. So here in this state is like all zeros, and this state is all ones. So this is what you no, but that's also not true. What I was going to say, because those are opposite, because those are kind of have the opposite phases, and that's why they change. That's why this works. But as soon as you're flipping one of them, right? So now this guy and its opposite, sorry, this guy and its opposite, they have the same, so they have a relative phase of 0. And so it's got to do with can't figure it out. I can't figure it out, but I will. I definitely will, because I feel that's an important tool. And I'm going to spend as many videos as it just takes to understand that before I move on to anything else. So stay tuned for many more videos about this. Oh man, I messed up with all that so much. So yeah, I'll just probably record the saved version before, but that's definitely, oh my god, why is this happening? Dun, 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 dun. It has to do with the fact that it's superposition that is created with all ones, and so this has, and we are breaking that imbalance here, right, by flipping these. So what this operation is doing is always, this operation, it seems it's trying to bring that back, but in order to do that, there is a price. There's a price to pay, price to pay, and cool. Stay tuned for the next video.